Hi everyone. We're going to graph these two functions, and for the first one we're going to test for continuity at x equals 0, and for the second one we're going to test for the continuity of x equals 1. So the first thing we're going to do is test for continuities, and we're going to take the first one. The definition of continuity is explained by these three conditions. So it has to meet these three conditions in order. And what I'm going to do is test for the first one now. So our C is where all the actions taking place. So it's changing, our functions are changing around 0. So I'm going to test f of C, and our C happens to be 0. So we plug in 0, and we have to plug it into this lower portion because that's where it equals 0. So let's plug that in. Square root of 0 plus 2 equals 2. So it does exist. So condition 1 is satisfied because we got a number out of it. All right, number 2, we've got to test the limits. So what that means is if the limit, we're looking at this right here, the limit as x approaches 2 from the left, 0 from the left of my function, that should equal the limit as x approaches 0 from the right of f of x. And all that means is that approaching 0 from the left means all numbers smaller than 0. So left of the graph. So here's your 0. So all these numbers as it approaches 0 from the left. So that's the negative numbers. That means we're here. So all numbers less than 0 is going to be 2. So that's just 2. Now, for all numbers greater than 0 as it approaches, so that means from the right would be coming from the right. That means all positive numbers. So that means I have to use this one. And we already did that one. And that equals 2. So they do equal each other. Since they equal each other, then our limit exists. All right. That means the limit as x approaches 0 of f of x equals 2 because they match. So condition 2 is satisfied. And for condition 3 to satisfy, my limit as x approaches 0 of f of x should equal my f of c. Well, my f of c, which is right here, was 2. And my limit of x approaching 0 is also 2. So they do equal. So condition 3 is satisfied. That means this function is continuous. And when we graph it, I'll show you what it looks like. Okay, let's try this one. So does f of c exist? Now in our case, this c is 1 because this is where all the changes are occurring. C equals 1. So f of 1 equals 2. Now we're going to, we did get a value at f of, f of 1 is not 2, sorry. F of 1 has to go into this one because it has to equal 1. So that's going to be square root of 1 plus 2. Square root of 1 is just 1. So that's going to equal 3. Now let's, condition 1 is satisfied. So we try condition 2. So the limit as x approaches 1 from the left of f of x, does that equal the limit as x approaches 1 from the right? Again, so here's your 1. So all numbers less than 1 as it approaches 1. So all numbers less than 1 are going to be 2. And all numbers greater than 1 I plug in here. So I plug in 1. Let's put f of x here. And we already got a 3. So that equals 3. They do not equal. So this is not true. Our second condition is not satisfied. So this function is going to be discontinuous. because it doesn't follow, it failed condition 2. So now let's graph them and see. So we know the first one was continuous. So let's graph this. Our C is 0, so let's just put a 0 here. Now at 0, or the numbers less than 0, it's always, our y is going to be 2. So at 0, let's go up to 2, but do an open interval. All right, so this is your y part. These are your y's. All right, so that means it's always going to be 2. Remember, this 2 can be rewritten as y equals 0x plus 2. That means it's a constant function. All right, now this one is all numbers bigger than 0. So I plug in 0 and I get 0. If you do a table of values, plug in 0 in here, you're going to get 2. And it can equal it. So that means it's going to override this open interval from here. Now, if you plug in 1, you're going to get 3. So it's 2, 3. Let's plug in 4. 4, you're going to get 4. And what's the next one? We take a square root of 9. Let's see. This is 4, 5, 6, 7, 8, 9. If you plug in 9, that's going to go to 5, map to 5. And so that's just your square root function that has been shifted. It's going to go up like that. Shifted up by 2 units. So now you can see why this is continuous. So if I take this, start down here, and just go left to right, I can draw this without lifting my pen. So that means it's continuous. All right? Now let's graph the second one. Okay, so we're going to take this first one, and our C, or our everything, where everything's happening, happens at 1. So for the first one, if I go to 1, that goes to 2. But it can't equal 2. So that's going to be right in here. All numbers less than 1 are going to be equal to 2. All right. Now, for the second one, all numbers greater than 1 are going to go to the right of 1. So if you plug in 1 here, you get square root of 1 plus 2. That equals 3. So that goes to 3. And then you can plug in, let's plug in 4. So 2, 3, 4. Plug in 4, that goes to 4. And plug in 9. 5, 6, 7, 8, 9. That's going to, square root of 9 is 3, so that's going to go to 5. So here is that. Now you can see why this is not continuous. All right, because it jumps. If you draw this, and you go to here, you have to lift your pen to go up here. So this is why it's not continuous. This is called the jump discontinuity. And that is why condition 2 failed. All right. Thank you. Have a nice day. Bye-bye.